Yeah, everyone, it's Vicky here, and in this video we're looking into cloth simulation in Houdini using Vellum. In my last Vellum video, I showed you how to use the shelf tools. This time we're going to set up the simulation from scratch to create a simple sail. We're going to set up the sail geometry, Vellum simulation, sailcloth properties, constraints and pinpoints, then save the cache data, refine the simulation, apply materials, and finally prepare the scene for rendering. Without any further ado, let's get started. As always, before starting any simulation, we first need to do some research. So I found several images online to help me understand how sails work, as well as different types of sails, different types of fabric, cloth used for sails. I also learned some terminologies such as mast, boom, main sheet, and halyard, which we'll use in today's video. So I invite you to watch either step-by-step guide to sailing or some sailing theory. I attach videos in the description that I watched to prepare for this project. Before we do anything, please make sure you set the project correctly and also save your scene. If you want to have the same desktop layout as I do, you can change from build, which is the default, to technical desktop. And what I also did is I collapsed this pane over here. Okay, I cannot remember on top of my head how the sail looks, so what I will do is import a reference image. So it's always very helpful to have reference image. Okay, so let's click on this icon over here, then select your reference image. I sourced this one online and just click accept. And here we go, that's our reference image. We can now go to the tools, edit background images, and we can move it to the side, we can resize it, we can change its opacity. Once you're happy with how it looks, let's go to the tools again, switch off, edit background images. Let me just zoom in and show you several things we're going to create. So we have our head sail, the main sail that we're going to create and use the cloth simulation on. And we also have the mast and the boom. These two things hold this sail so that it looks as it looks, okay? So that it's stretched between these two things. So we have the mast and the boom. The boom rotates around the mast, so this allows the sail to rotate to change direction. Okay, so what we'll do is we'll start with a simple geometry, so just an empty geometry network, and I'll rename this one to mast and boom. Okay, and let's dive inside. And we're going to start with a simple tube geometry, so just a tube. And let's have a look at the settings. Let's go from the top. So first of all, we want to change it to a polygon. Then we want to switch on the end caps, so the top and the bottom end caps, we want to close our geometry. And we'll also decrease the radius. So I'll decrease it to about 0.2, so you can see the radius at the top decreased. I can also manually decrease the second one, so I want exactly the same value. But to save some time later on when we adjust things, I can just right-click on the first value, copy parameter, and then right-click on the second value, paste relative reference. And what it does is whatever I type in here, it will copy it to the second value. See, so now I can only write it once and it works in two fields. Brilliant. The next thing I want to do is increase the height. So let's increase it all the way up to 10. Then I will also increase the subdivisions. So maybe let's see 50 by 50. So 50 rows, 50 columns. So you can see you have much more subdivisions over here. Okay, so let's create a transform node. And I want to use this transform node so that this tube sits nicely on the ground. So it's not halfway through the grid, it sits nicely on the grid, okay? And what we can do here is use a very simple expression. So what we'll type here is minus $ y min. You might already know it, all block capitals, and then press enter. And now you can see the tube moved to this point over here, so now it sits nicely on the ground. But if I switch on show handles, you can see that the pivot point is in the middle, still in the middle, which means if I increase or decrease the uniform size, uniform scale, our point over here changes, so it's not on the ground anymore. So what we need to do is go to pivot transform and move this pivot point to the bottom of this tube. And we'll use exactly the same expression as we did here, just without the minus. So $, y min, all block capitals. And we're typing y. Why are we typing y? Because it's y-axis, so it's x, y, and z-axis. Brilliant. So if I now increase or decrease the uniform scale, you can see it's on the ground. So I will just right click on where it says uniform scale, revert to defaults. Okay, so that's our default value. Once it's done, so that's our boom, our mast, sorry, I can drop down null, display it, and rename it to out mast. Brilliant. As an alternative to using the transform node and this simple expression to move the tube to the center, you can also use game dev tools. So let's first change the desktop type to games. Then let's go to the side effects labs tab and make sure that you have all these tools in here. If you cannot see them, then click on update toolset and then update. Okay, so let's go back to our technical workspace, technical desktop. Let's go to the tab menu and we want to use something called axis align. So it's this one over here. Let's connect it. Okay, and display. And now we can see we have justify X, Y, and Z options. And this one allows us to do exactly the same thing. So we can move it so that it's aligned with the minimum, maximum Y axis and so on and so forth. And the same with X and Z. So you can either use the transform node with these expressions or the alternative, so the axis align. Let's just delete it because I'll use the transform node. So the second thing we want to do is create the boom, and it's going to be quite simple. So we have the tube. We don't want to create another tube because we have one already. So what I will do is just link another transform node over here. Okay, so it will use the same tube. We'll use the same tube for the mast and for the boom. And in this transform node, I want to move this boom up and then rotate it. So it creates a triangle with the mast. Okay, to see it better, let's create null. I'll rename it to out boom. And I'll also create merge to merge the mast and the boom so that we can see both of these at the same time. Okay, let's select the second transform, so the transform node for the boom. And what I want to do here is simply rotate this boom by 90 degrees, so minus 90, and also scale it down. So if we look from the side, you can see that it's a bit too long, so I'll scale it down to maybe 0.55. Okay, that's fine. And I'll rename this transform node to rotation and scale. Let's now create another transform node, and I'll use this transform node to move this geometry up and also animate it, so it will rotate around the mast. So first, I will move the boom several units up, so about 3 units in y-axis. And I also want to move it to the side so that it starts somewhere over here. To do it, I also need to move the pivot point to either end of this tube. So I will switch on pivot transform options, expand pivot transform options, and use our expression here again, this time in Z-axis. So if you look at the axis over here, you can see this one in this direction is Z. So I need to type $, Z min. Okay, and now we can see it moved it to this end over here. If I want it to be over here, I can type minus at the beginning. And now I can move it to the left. How can I do it? Well, I'll use exactly the same expression, just with the minus at the beginning. So minus $Z min. Here we go. But what you can do, you can see here is that this boom intersects with the mast. We don't want to do it. We don't want to have it. So what I will do is add some value over here. So let's add, for example, 1 for start, to move it a bit more to the left. So what value should I add here? If we go to the tube, we can see that the radius of our tube is 0.2. So from the center to the left, we have 0.2 units and the same to the right. So the whole thing has 0.4 units. So it's 0.4 units wide. So what we can do here is copy this value. So right click, copy parameter, go to the second transform. I'll expand it just a bit. And after the plus, I'll get rid of the 1. After the plus, I right click, paste relative reference, and then enter. So now you can see that it moved the second tube, the boom, exactly to this point over here. It's not intersecting, it's exactly next to it. Brilliant. So now what I want to do is animate this boom so that it rotates around the mast. However, if I rotate it, when I rotate it, you can see it starts intersecting with the mast. And it's again because of our pivot point. So our pivot point should be here in the center instead of here on the side. And what we can do is use the same value. So from the tube, we can use the radius, but this time subtract it from this pivot. So we want to move the pivot a bit to the right. And how do I know I need to subtract it? Well, if I look at the axis, I can see that if I want to move something to the left, it's positive value, so I need to add it. If I want to move something to the right, to this side, I need to subtract it. So where you see the line, it's always positive values, and the other way is negative values. So I could just copy it from here. Okay, so Control C. And now I'll type minus and Control V to paste. And now we can see the pivot point is exactly in the center where we want it to be. So now when I rotate the boom, you can see it doesn't intersect with the mast. Perfect. So one more thing, one more expression I will use here is the expression that will animate this boom around the mast, so that we don't have to do it manually. Of course, we can set keyframes on the first frame, on the frame 250, but if we were later to make this timeline shorter or longer, we would need to change it. So it's better to use the expressions. So what I will use here is sign, open brackets, $FF, which means the current, the frame, okay? Close the brackets, press enter. Okay, you cannot see it move. However, if I scroll the timeline, you can see it moves. It just moves very, very slowly. And also the angle is quite small. So what I will do here is first multiply it by, let's say, 50 and play it again. Now you can see that the angle is bigger. So it moves like this. And I will also multiply the frame value by, let's say, 2 to speed it up. Brilliant. So let's rename the second transform to pivot, move, animation. So our 3 things. And now the boom and the mast are ready to go. And one more thing we need to create is something to attach the sail to. So I will create line over here just next to the mast, and the sail is going to be attached to this line. This line, in proper terms, is called a halyard. So it's used to raise the main sail. It's connected to the head, to the top of the sail. So if we want to be able to raise the sail in Houdini, we need to do it properly by using the halyard. So let's create a line. Here's our line. I will just switch on point to display points so that we can see what's happening here, or even point numbers. Let's display the line. And I'll also create a null so that I can attach it to the merge node. And I'll rename it to out halyard and connect it to the merge node. Okay, that wasn't a good idea. Let's switch it off for a second. So the origin of our line needs to be exactly the same as the origin of the mast. So what I will do here is go to the tube and then right click on the center, copy parameter, go back to the line, right click on the origin and paste relative reference. So now I know that whatever I change in the tube, if I move it, the line will move together with the mast and the boom. Let's go back to the line. Now I want to make sure that the direction is set to 1 in y-axis, so it's parallel to the mast. And now the length of this line, of the halyard, will be exactly the same as the length of the mast. So which value can I use? Well, I will go back to the tube again, and this time copy the height. So right click on the height value, copy parameter, go back to the line, and right click on the length value, paste relative reference. And how many points do we want? Let's use about maybe 12. And if I zoom in, you can see that the line starts over here and ends at the top. But I want it to start over here and end at the top. So I need to subtract something from this length. So I will go to our pivot move animation and see at which point the boom starts. So this is our value, number 3. Okay, so I will copy this value, copy parameter, go back to the line, and now in here, I will subtract from the length this value, so paste relative reference. So we'll have the tube height, so 10 minus 3, so the position of the boom. And let's press enter. So now we know that, or if I were to move this up, it will be exactly from here to the top. Brilliant. Let's add color node so that we can see the line. So it can be any color you want. We'll not render this line later on, so maybe red so that we can see it. If you want to, you can switch on wireframe to see where this line is, if that helps. And the next thing we want to do is align this line with the boom. So let's create a transform node after the color node. And I will rename it to align with the boom. Okay, so first of all, I want to move it to this position. How can I do that? Well, I need to find this value again. So it's our translate value in y-axis, right click, copy parameter, go back to align with the boom, and in the y value, paste relative reference. Click enter, and let's see if that's correct. Okay, we can see it's exactly in the middle of our tube over here. So what we need to add again is the radius of the tube. So I will go to the tube, right click on the radius, copy parameter. It's a lot of copying parameters and pasting parameters, but it will pay off when you change the settings, and they are all nicely linked so that you don't have to change them everywhere. Okay, so in the translate Y, you just right click, click plus, and then right click, paste the relative reference, and then enter. So now you can see it starts over here. It will not be intersecting with our boom, or it's intersecting with the mast. We will fix it in a second. So if we want it to be a bit to the left, we'll again use the same value. So the tube radius, we can just copy that value. Okay, so let's copy that value. So from here, I just copy the radius of the tube. Okay, press enter, and I will paste it in here. Click enter. Now you can see is exactly next to the mast, and I want to add maybe 0.1 to it, so it's not that close to the mast. We can adjust it later on. So we have the mast, we have the boom, we have the halyard. What else? Let's play it. So you can see when the boom rotates, the halyard doesn't follow, so it stays in place. So our sail will stretch, so we need to fix that as well. So what we'll do here is use another transform node. You can see how much we can do with simple transform nodes, and rename this one to follow boom rotation. So let's find the value that animates the boom. So it will be in pivot move animation, and I will copy all rotate values. So right click on rotate, copy parameters, go back to Vellum boom rotation, and in the rotate value again, right click, paste relative reference, click enter, and now you can see that it follows the boom. Okay, maybe you do not want to make the halyard follow the boom. That's fine as well. So just you can set it up and then later on adjust it if you want to. What I will also do for the halyard is change the pivot transform. So I will switch on pivot transform, and again use $y_min because I want the pivot to be at the bottom. And now what I can do, the final thing here in this network, is animate this halyard. So our sail will be attached to this halyard over here. So if we want to raise it, we need to first shrink it down, okay? So we need to make the halyard smaller, and then we'll raise the sail. Okay, so let's switch off pivot transform. Let's scroll up and go to the first frame. And I want to set a keyframe on y-axis scale. So you can see this one scales the halyard up and down. Okay, so alt click and click on the value. It will set a keyframe. And on the first frame, I want it to be 0. Actually, no, you know what? I want to, let's undo that. So Control Z and Control Z until you cannot see the keyframes anymore. I want to go to frame 25. Let's just give it a bit time, okay? And now let's set the keyframe. And I want the sail to be raised. So maybe like so. Okay, so 0.95. Then I'll go to frame number 50. Then make it 0. Hold down Alt, set a keyframe again. Then go to frame 75, set another keyframe. This one will be on 0 as well. Then move to frame 100 and raise it. So 0.95, make sure to set a keyframe. So it should change the color to this nice green, okay? So now when I play it, you can see it lowers, then it raises. Brilliant. That's exactly what we want. So to see the halyard better, what we can do in here is simply create something called wireframe. Okay, wireframe. This one will create geometry out of this simple line. Let's switch back to smooth wire shaded. And you can see that our halyard is definitely too thick. So let's decrease this thickness. Maybe 0.5, 0.05 or even less. 0.01, and I will switch on end caps. So finally, make sure the merge node is displayed. Now we can go back to the object level, and this is our mast, the boom, and the halyard. It's all ready. So now we can create the sail itself. So let's create an empty geometry network. Rename it to sail. Let's dive in, and in here we will start by creating something called a planar patch. Planar patch, where is it? Here we go, that's it. So I will scroll down and change the shape to trapezoid, and then let's go to the taper option because we can definitely not see any triangles here, and let's decrease the taper to 0. Now I will also decrease this value so that we can see we have a nice triangle, okay? So minus 0.5. And I'll also increase the scale to maybe about 5. Let's see. Okay. Let's now create a transform node. We'll place it in position and then adjust it. So let's display the transform node. So in the transform node, first I want to rotate it about 90 degrees. Then I'll move it up. Let's see. Okay. You can adjust it manually in the viewport if you want to. And now I can go back to the planar patch and increase the size, the second value, so that it's taller. Okay, that looks about fine. So now I can create another null. Let's display it and rename it to out sail. Brilliant, let's save our scene. So we have the boom, we have the mast, we have the halyard, we have the sail. Everything is ready. So what we can do now is start the simulation. In my last tutorial, I showed you how to use the shelf tools to create cloth simulation. This time we're going to create it from scratch, so just using the tab menu and the nodes that we have over there. And what you will find is that it's actually a bit easier because you have control over what's happening. So you see how the network works, you know how to change all the parameters. So Houdini doesn't create it for you, you need to create it, so you learn more. So the first thing we need to do here is let Houdini know that what we want to create is a cloth simulation. So let's go to the tab menu. Let's type Vellum configure, I cannot spell, Vellum configure cloth. So you can see we have several ones. So we have configure balloon, cloth, grain, hair, short soft body, tetrahedral soft body. So depending on what you want to create, you choose this one, okay? So Vellum configure cloth, let's create it. And now we have 3 inputs. So we have Vellum geometry, we have constraint geometry, and we also have collision geometry. But the first one is marked red, which means that's the one we must use. And vellum geometry is just our geometry we want to simulate. So it can be the sail in our case, or piece of clothing, etc., etc. Okay, so let's connect it. And now let's display vellum cloth. And if I zoom in, you can see these white lines. I discussed in my other video that these are the constraints. So the white lines, the constraints between the points. If I display out sail, you can see our subdivisions. If I display vellum cloth, the constraints, you can see different lines. So these are not subdivisions. These are the constraints. So if we look at the settings over here, you can see that we can change a lot of different things. So let's go for the top. It will be the same as for the shelf tools. So when you use the shelf tools, you will also find this node. And in this node, we can change the properties, the behavior of the fabric, so the type of the fabric. And what I found is that some sails are made of something called dacron. Okay, so let's type it here. And what I found about dacron is that it's extremely lightweight. So first thing we need to change is the mass. So if you scroll down just a bit, you can see mass and then density. So mass of your fabric is calculated based on the number of points on the geometry. So the more points you have, the heavier the fabric. So what we set here is not the mass of the whole fabric, of the whole thing, of the whole sail. It's the mass of each point on the sail. Okay, so let's decrease it to maybe 0.1. Because it's lightweight, I can also imagine that it's quite thin, so I will decrease the thickness as well to 0.01. You can click on visualize thickness, and here you will see these points. Okay, if I increase the thickness, you will see that these spheres get bigger and bigger. Okay, so you can visualize thickness. You should not make the thickness higher than, well, in this case, let's see, let's find this value. About that. Okay, so you don't want the spheres to intersect, so you need to check that. But I want it to be very thin, so I'll decrease that to 0.1. And now I can switch off visualize thickness. Okay, so these are our two main settings. Let's scroll down and see what else we have here. So we have stretch. So stretch is how much the fabric stretches. For the sail, I imagine it's not very high. So what I will do here is increase the stretch stiffness. If you hover over, you can also read a bit about it. And you can see that the stiffness of the constraint, which controls how strongly the constraint pulls particles back towards its initial rest state. So what it means, I'm not adjusting the stretch of the fabric, of the polygons, of the points. I'm adjusting the stretch of the constraints. So this is something to remember, okay? I'm adjusting how these white lines behave. So I'll increase the stiffness to 100. And I can also increase the compression stiffness. In the stiffness, stretch stiffness, you can see it also tells us that we can change it by factors of 10. So if I had it by default 1, I will not change it to 2, I will just change it straight away to 10. So that's why I changed it to 100. So if I want it to be quite high, I can change it to 100, okay? I'll also increase the compression stiffness just a bit, so maybe 0.5. Okay, let's scroll down. So the next thing is warp and weft. I also discussed it in my other video on cloth simulations. And plasticity. So this is what creates folds on the fabric. So we'll not use it for this one. If you scroll down, you can also see bend stiffness options. And actually, I want to increase it. So I'll increase the bend stiffness to about 30. And I'll leave the damping ratio, rest angle scale, and everything else as it is. So we'll leave the settings for now, okay? Then we'll see how it looks and we can go back to the settings later on. Let's play the scene. Let's see if anything happens. So you can see, even though we added Vellum constraints node, it's not animating, it's not behaving as a cloth. And this is because we don't have the brain for the simulation yet, so we don't have Vellum solver. So let's go to the tab menu again. Let's type Vellum solver. And as you might know from my other videos, we only have one solver for Vellum simulation. So for cloth, for wires, for grains, etc., etc. Okay, let's zoom in and let's see what inputs we have. So we have Vellum geometry, we have constraint geometry, and we also have collision geometry. The first two we must connect. So we'll connect the Vellum geometry output to Vellum geometry input and constraint geometry output to constraint geometry input. And now we get this error. Okay, I'll just save, don't crash. And I will display Vellum solver. Play the simulation now, and you can see that the sail just falls down. It doesn't interact with the boom or the mast. It doesn't interact with the ground. We don't have any ground. It just falls down. So what we can do in here, well, normally we would just go to collisions tab and create the ground plane, but we don't want to do that because that would create an autodop network. We want to do everything in this geometry, in the SOP level, okay? So what I will do is select the Vellum solver and have a look at the options here. So first of all, we have start frame. So we can ask Houdini to start the simulation at frame 21. So now when I play, nothing happens. And then on frame 21, the simulation starts. I will change it back to 1. Then we have time scale. So this is how fast everything is happening. So you can slow down or speed up the simulation. So if I type 0.5 and play it, you can see it's much slower. If I type 4 and play it, it will happen super fast. Okay, I'll right click, revert to defaults. Then we have the sub steps. So this is the quality of our simulation, how many times per certain time the simulation is recalculated. So if you want to have very precise simulations, it's best to increase that value. And usually substeps and constraint iterations are linked. So what it does is it multiplies these two values. So if I have one substep and 100 constraint iterations, I get value of 100. If I increase the substeps to 5, it gives me 5 times 100, which means 500. So if I want to still have 100 in total, I need to decrease that value to 20. Okay, so I would just advise you to do that to keep your simulation good quality, but also quite quick. And what we have over here is collisions. So we can enable collisions or disable collisions, and we can also switch on the ground plane. So if I switch on the ground plane and play it now, you will see a very interesting thing. First of all, our simulation is much slower. This is because I increased the substeps, and also it interacts with the ground, which is amazing. So we do not need to create a ground plane. We can just switch on ground plane in the Vellum solver. Let's scroll up and now let's go to the forces tab. In the forces tab, we can adjust some basic forces such as gravity or wind. We can also adjust friction by adjusting the static threshold, and this is important as well. You will use it quite often in cloth simulations. So this is how much the cloth slides, okay? So remember that static threshold, the friction, is over here. Let's add a bit of wind. So maybe let's type minus 10, and let's see which way it goes. Okay, so we have x-axis over here. I didn't want to do that. I want it to be in minus z. So I'll switch it back to 0. So x, y, z, minus 10 now, so that I can see the interaction between the sail and this tube, so the mast. It's not interacting. And why is that? Well, it's because we didn't link our mast and the boom to the simulation. If I go to this option over here and hide other objects, you can see that it's not here. It's not in this network. So Houdini doesn't see it. So what I can do here is create object merge. Okay, object merge node. And in object merge, next to object, I just link my mast and boom network. So it's this one over here. Let's click accept. And by default, it will link it to the last node in our mast and boom networks. If I click over here, okay, you can see it goes to the merge. It's linked to the merge nodes, to the last node, to the displayed node in our network. Let's go back to the sail. So this is why I see everything over here. And now what I can do is link this to either collision geometry over here or to the Vellum solver. So let's link it over here and then connect this line so that we have our collisions. Let's play it. Here we go, so now it's interacting. Normally when you create vellum using shelf tools, you would use Surface Collider to achieve the same effect. So the next thing we want to do is connect the sail to the halyard and to the boom. We can do it in Vellum Constraints. So if you select it, you might already be familiar with pin to animation, so the pinpoints. However, if I select the pinpoints, so let's click on this icon over here, and now let's select my pinpoint. So I select the point at the top, then click Shift and A to select everything in between, okay, and then enter. And now play the simulation. Okay, you can see that it works fine. It works fine, but when the halyard lowers, the sail stays in place. So in here we can see the halyard. Okay, it's halfway through, but the sail is still raised. So we do not want to use that. So let's go back to Vellum Constraints, and I will just select everything, Control A, and then delete and enter. So instead, I want to use something called Vellum Attach to Geometry. And now once you found it, let's just hover over these lines. They will highlight white and then click. Okay, and now you can see that it's connected properly. So we have all three inputs and outputs connected. What I will also do is get rid of this connection and this one. And I want to connect Object Merge straight to Vellum Attach to Geometry. Okay, so just one node later. So what Vellum Attach to Geometry allows me to do is pick points on the sail and then pick points on the collision geometry. So it will be attached to certain points on the collision geometry. Let's display it. Scroll up in the options, and first of all, I want to choose the group. So the geometry group. Let's change this to points, so group type points, and let's click on this icon over here, and we want to select the same point. So first we'll select point on the sail. Okay, Shift A, and then enter. If you cannot see the point numbers, just do the same thing again. Okay, so make sure you can see the point numbers over here. Now let's scroll down, and now we have the target geometry. Let's change the target group type to points as well. And then next to target group, let's click on the selection icon again. And I want to select all these points. Okay, let's click escape, and I'll do one more thing here. So let's go back to the object level. And now what I want to do is duplicate mast and boom. So hold down Alt, drag it down. Okay, so I'll have mast and boom for simulation, and I'll have mast and boom for render. Okay, so in Mast and Boom for simulation, we want to bypass the wireframe or just get rid of it. So we do not want the wireframe, we just want the line. Okay, let's go back to the object level. And we can hide this one. So what we'll render is Mast and Boom render. Okay, but what we'll simulate is Mast and Boom simulation. So the only difference is the wireframe node. Let's dive inside the sail again, select Vellum Attach to Geometry. Find your target group, and next to target group, click the selection icon. Make sure you have target group type set to points. Now I will select the first point at the top, and then this one here at the bottom. So click Shift and A and select the one at the bottom. And now we can see all the points are selected. I'll click Enter, click on Vellum Solver, and play the simulation again. So now you can see the sail lowers with the halyard. Okay, brilliant. So this is exactly what we want. Now we need to create another Vellum Attach to attach the bottom of the sail to the boom. So let's type Vellum Attach to Geometry. I'll create it over here. So this one will be the halyard, and this one will be boom. So we'll do exactly the same thing. Let's scroll up. So in the geometry, change the group type to points, then take the selection icon, and we'll select these points over here. So Shift and A, press Enter. Now scroll down. And in the target geometry, change to points as well. Target group, select. And I want to select these points over here. So starting with this one. And which row is it? Let's try to find it. Is this one? I think it's this one. Let's see. Okay, brilliant. And let's click enter. And now you can see the sail is attached to this geometry. You can also see these lines over here. And these lines represent the distance between the target geometry, so the boom, and the sail geometry, our cloth geometry. When I play the simulation, let me just change back to smooth wire shaded. So when I play the simulation, you can see that this distance is preserved. It will always be the same. Houdini will try to keep it the same. But I want the sail to be as close to the boom as possible. So what I will do is select volume attached to geometry. So this one, the boom. Then scroll down and decrease the rest length scale. Let's decrease it to 0.3. And now when I play it, you can see that the sail on the very first frame, watch closely, it moves closer to the boom. If you want this distance to be equal to 0, in your vellum attached to geometry, you just change the rest length scale to 0, and now you'll see it's kind of stuck to the boom. Okay, I just want to move it a bit away from the boom. Okay, perfect. And I'll go back to my solver, to the forces, and now I want to adjust the wind. So maybe let's try -10 over here, and let's see. Okay, that works fine. So our simulation is all set. You can see that the boom is following, the sail is following the boom. The sail is also raised at frame 75. The sail is also lowered at frame 25, so everything works perfectly fine. So once we're happy with how everything looks, we can cache our simulation. So let's create something called Vellum IO. Okay, let's connect all 3 outputs and let's display it. And that's the node that allows us to cache our simulation and then load from disk, so just to make everything quicker. So what I will do is save this frame range, maybe a bit lower, 100 frames. Okay, save this frame range. So from 1 to 100, save it to the disk and then read it from the disk so that I can see it more or less in real time. So just remember about the naming convention. So it needs to be the name of the file, so you can name it however you want. Then $F, which means you will cache more than 1 frame. Then the extension. Okay, so I'll just copy these, Control-C, click over here to choose where to save it. I'll rename it to sail $F.bgr.sc. If you want to add frame padding, just type the frame padding after F. Okay, let's click accept and let's just save to the disk. Once it's done, you can simply load from disk, and now when you scroll the timeline, it will just read what's happening in the scene. So after Vellum IO, I will add one more thing called Vellum Post Process. Again, make sure all 3 inputs outputs are connected, display Vellum Post Process, and what this node allows us to do is post-process our simulation after caching. So we'll not simulate anything anymore, we'll just increase the quality. We can increase the quality of the simulation without the need of resimulating. So Vellum Post Process, let's have a look at the options. So first of all, we have something called smooth, and we can smooth our geometry, our cloth, by using either Catmull-Clark or loop. We can increase the subdivisions depth, and if I scroll the timeline, you can see it doesn't resimulate. It just adds subdivisions, it calculates it to make the simulation nicer, smoother. Okay, then we have something called detangle. Detangle doesn't work on the collisions, so if you have incorrect collisions in your scene, it will not work. It will work only on the self-collision created by the post-process node. So for example, if I extrude my geometry, so that's the third option, extrusion. Okay, so you can see now it's extruded. You will sometimes see when the fabric folds, you will see that it just collides with itself and it can intersect. So this is what fixes that issue. Okay, I will just switch it off. I don't want it to be too slow. Now, depending on the thickness that you used in our Vellum Cloth Dacron node, so if we scroll up, depending on this edge length scale, edge length scale, this thickness will also be visualized differently. So if you increase the thickness in our Dacron node, and you switch on thickness here and change it to 1, this material will be thicker. Okay, so this is why it's important as well. So you can adjust this value over here. You also have another tab here called Visualize, and you can visualize thickness. You already recognize these, okay? Fail self-collision, okay? Failed external collision, and then we have wells, and so on and so forth. But also these visualizations here at the very bottom. So let's go to the drop down menu and now switch them on. And this is a very nice way of seeing what's happening inside your simulation. So you can visualize the stretch, the bend, you can visualize plasticity, and it just makes adjusting these values over here much easier. So once you have that and understand how it works, you can adjust these values in your Dacron node much easier. Okay, let's switch it off. The final thing left is just rendering. So I will drop down material node over here. I will also drop down merge because we don't have the collisions. So I want the collisions. Where are the collisions? Here you go. So I will create another material node over here after the collisions. Okay, so this is our mast and boom. And also connect it to the merge node, display the merge. So now we have our simulation. What you can do next is create a material node for the sail. You will link it here, and create material node for the boom. You will link it over here. If you want to use different boom and mast for rendering, so you want to use, instead of your simulation, you want to use the render. So for example, you want to see the halyard, or you want to add subdivisions on the tube, then you just hide the simulation, mast and boom simulation, display mast and boom render, and then add the material over here. So after the merge, you can add the material node over here and apply your materials here. For the materials, we can, for example, use, let's go to the material palette, some presets. So first of all, let's have a look. We can use coated metal paint, so that is not too shiny. And I will also change the color to maybe something gray. So that will be for the tubes, for the mast and for the boom. And for the cloth, so for the sail, we can use, for example, blue cloth or red velvet, soft beige leather. So maybe blue cloth, and I will just change its color to white. Let's go back to the object level. And I will apply this material over here. So let's just choose it from the drop-down menu. Cloth, accept. Oh, it's not this one, sorry. Coated metal, of course, that's for the mast and for the boom. And I will go inside the sail. And I will display this one, so I don't want to use the collisions for the render. I will just use the sail. And in here, I want to link my cloth. Go back to the object level. And now you can see it. What you will also need to do before rendering is, of course, set up camera. So go to new camera. And you can position it by clicking on the padlock. So I'll position it maybe like so. Okay, click on the padlock again once you're happy with the position. And I also want to create the lights. So I will go to the lights and cameras tab, and you can either use environment light and HDRI, or you can use skylight. Let's use the skylight. So you can see the background, it creates the background for you. And you can also add 2 more lights, so distant lights, to add a bit more depth to the scene. So we'll have distant light blue, and we'll also have distant light yellow. Okay, distant light blue will of course be a bit bluish. And we'll add a bit of, yellow tint to this yellow light. And now we can position them. You can also decrease the intensity of on both. And now you can start doing some test renders. Remember to use your camera for the test renders. And that's your scene ready. So we created the mast, the boom, 2 versions of them. So one for the simulation, one for the render. We also created the sail and applied a simulation to it. And everything is working nicely. And that's it for today. I hope you enjoyed it, and I'll see you in the next one.